Okay guys, so again, we're going to continue with solving systems of equations, but right here we have some real world situations. So let's take a look at number 1. It says, vegetable stand. A roadside vegetable stand sells pumpkins for $6 each and squash for $4 each. One day they sold 7 more squash than pumpkins and their sales totaled $228. Write and solve a system of equations to find out how many pumpkins and squash they sold. Okay, so we need to take this one sentence at a time, and we need to eventually create a system of equations. So we're going to create 2 equations, and I'll tell you what, whenever we create these systems, one of them is most of the time going to be based on money. All right, you got to create an equation based on money. So let me do this right here, and everybody should do this. On number 1, let's put a little money symbol. And let's make an equation based on money. And then the other equation is going to be based on numbers, right? Like on the actual number of pumpkins and squash that we sold. So we're going to make one equation based on money and one equation based on numbers. Okay? So, and that's going to happen on most of these word problems. So let's begin with the money equation. Okay? When we read over here, it says pumpkins sold for $6 each and squashes sold for $4 each. Okay, so when I create this first equation with regards to money, how much were the pumpkins?
6.
Okay, so I want to put a 6, and I want to put a P right next to it representing $6 for each pumpkin, right? The P is really the number of pumpkins, right? So if I sold 10 pumpkins, well, 6 times 10 would be $60. That's how much they made in pumpkins, right? Okay, so we're making an equation based on money. So $6 for each pumpkin. How much was the squash? So we're going to add $4 for each squash. Okay? So this is an equation based on money. Okay? Now, how much was the total amount of money made when they sold it at this price of $6 a pumpkin and $4 a squash? $228, right? That's what it says up there. Okay, so that is an equation based on money. Does everybody understand how we came up with that equation? Yeah. If it would have been $5 a pumpkin, you would put 5 times P. If it were $3 a squash, you put 3 times S. Nice and simple, right? And then the total amount of money, there you go. Now, the other equation, the one I'm going to write above it, is going to be based on numbers. Okay, so could somebody tell me, like with regards to how many pumpkins and how many squash, like what do we have there? What do they say? They say that it sold 7 more squash. It sold 7 more squash than pumpkins. Now we're going to have to probably take a couple of moments to think about this. All right, so what do they sell more of? Squash or pumpkins? Squash, okay. So how many, like let's say they sold 10 pumpkins, how many squash would they have sold? 17. If they sold 20 pumpkins, how many squash would they have sold? 27. Why? Because it says that you have 7 more, right? Squash than pumpkins. So let's say this. I don't know the number of squash that they sold, right? I don't know. I want to put an S right there. But I do know that however many pumpkins we sold, the squash has to be 7 more. So the squash is whatever number of pumpkins sold plus 7. Does that make sense? Okay, once again, let's think this through. Okay. It says that we sold 7 more squash than pumpkins. So if I said, hey, they sold 10 pumpkins, oh, the squash must have been 17 because 10 plus 7 is 17, right? Oh, they sold 20 pumpkins. Oh, 7 more. That must be 27 squash that sold, right? It's always going to be 7 more squash than pumpkin. So what we need to do is take this expression and write it as an equation. Okay? So we're saying that whatever the number of pumpkins were sold, squash will be 7 more than that. Okay. Once again, 7 more squash than pumpkins. So whatever amount of pumpkins were sold, if you add 7, that'll tell you the amount of squash that you sold. Do we get it now? I know that's kind of tricky, right? I mean, right now we just need to understand that the squash number of squash sold is going to be 7 more than the number of pumpkins sold, right? So now from here we have a system. We created a system, and we're going to be solving this system with what method? Substitution, that's the best method. I mean, you could do all the other ones, but substitution looks best. Let's take this p plus 7 and let's put it right into the s of the bottom equation. So my bottom equation is going to read 6p plus 4 times p plus 7 equals 228. Now we are limited on space here, so what I want to do is distribute. So when I distribute, let me get a little closer here. When I distribute 4 times p, that's going to be 4p. I want to write it up here. 4p. And then 4 times 7, that's positive 28. But let me rewrite the rest of this equation. There's a 6p out in front and it equals 228. So a 6p out in front, and there's of course a plus in front of the 4p because it's positive, equals 228. Equals 228. Everybody with me? Okay. So now I could focus in on this single variable equation and find out how many pumpkins were sold. So when I go 6 plus 4, that's going to be a total of 10 pumpkins. I still have the plus 28 equals 228. So when I solve this guy, subtract 28, you will get a new equation that reads 10p equals 200, right? When you subtract 28 from 228, divide by 10. Divide by 10. How many pumpkins were sold? 20 pumpkins were sold. So P equals 20. Now you got to pay attention to what they're actually asking for. Are they asking for how many pumpkins were sold, or how many squash was sold, or both? Both, right? Oh, there's a typo up here. It says quash instead of squash. All right. Anyway, so if we want the other one, all you have to do is substitute the 20 back in. So remember, whatever pumpkins were sold, it says, we already know that 7 more squash were sold. So if I plug in the 20 right in here, it'll be S equals 20 plus 7, which is 27. So let me do that. Let me actually write it. S equals pumpkin plus 7. So you really have S equals 20 plus 7, which means S equals 27. So the full answer to this, and it should technically be in words, 20 pumpkins were sold and 27 squash were sold. So 20 pumpkin and 27 squash were sold. That's the answer. Let's move on to the next one. Honestly, I think number 1's the hardest right there. The next one, basketball. Okay, so this girl makes 17 baskets during her game. Some of these baskets were 2-pointers, obviously, and others were 3-pointers. In total, she scored 42 points. Okay, so what kind of equations, like this time we don't have money, right? There's no money involved. It's actually baskets and what else? Points, that's right. So we need to make an equation based on baskets, and we need an equation based on points. Okay? So you got to identify the two things that are going on in this problem, and you need to create equations, 2 equations based on those 2 things. So let's make an equation based on baskets. Now, this is going to be confusing unless we actually label some things. So how about this? Even before beginning, I want to go over here to the side, and I want to say that my x is going to be, let's say, my 2-pointers. Yeah, and my y's are going to be my 3-pointers. So this is a little note to myself just so I don't get confused. I want to call x's 2-pointers and my y's 3-pointers. Yay? All right. So let's make an equation based on baskets. Since I don't know how many 2-pointers or how many 3-pointers she made, but I do know that she made 17 baskets, I want to make an equation that says x plus y is a total of 17 baskets. Does that make sense? Okay, so again, make an equation based on baskets. Well, you don't know how many 2-pointers, you don't know how many 3-pointers, but you do know that it was a total of 17. That is an equation based on baskets. Now let's make an equation based on points. So how many points does she get for each of these x's? 2. So let's actually write that. Let's write down 2 times x, because she gets 2 points for each of those 2-pointers. And how much does she get for each of these y's values? How many points does she get for each of the 3-pointers? 3 points, right? So you're going to put plus 3y. Now, since we're talking about points, how many total points did she actually make? 42 points. Okay, so let's put equals 42. So this is half the battle right here. Being able to read it and being able to create it. You want to make one equation based on baskets. You don't know how many 2-pointers. You don't know how many 3-pointers. But you know if you add them, it's a total of 17 baskets. And then make an equation based on points. Well, for each of the 2-pointers, she gets 2. For each of the 3-pointers, she gets 3. That's why we have 2 times x plus 3 times y. And we know that she made a total of 42 points. So now let's find out how many of each type she made, right? How many 2-pointers she made, how many 3-pointers she made. How are we going to do that? By solving this system that we created. So let's get, what do you guys want to eliminate, x's or y's? X's? Okay, so if I want to eliminate x's, I'm going to have to take that top system and multiply it by -2. So you could put the parentheses with the -2 out there in the front, or if there's no space, you could always do this. Put times a -2 like that, just so you could write some notes to show how you're changing it. So the new top equation, if you are multiplying by -2, is -2x. It's going to be -2y, and it's going to be -34. Are you with me? Bottom equation, we're going to leave the same. 2x plus 3y equals 42. And now it's ready to combine the lines and eliminate the x's. So when I combine them, those guys eliminate, and I'll have 1y, right? -2 plus 3, that's just 1. You don't even have to write the 1, equals, and if you do -34 plus 42 on a calculator, you will get 8. Okay? So what do we just find here? Y is 8. What is y?
Y is 8.
So what is y? Y are the 3-pointers. So she made 8 3-pointers. Okay? Now we need to find out, wait, what's it asking for? Is it asking for the 3-pointers or the 2-pointers? It says how many 2-point baskets did she make? So they're not even asking for the 3-pointers. But you could write this down if you wanted to, that she made 8 3-pointers. But they're not asking for that. They're asking for the other one. So how do you find the other one? You substitute back in, plug it in. So if I take the 8 and put it right into the top equation, that'd be easiest. It would say x plus 8 equals 17. So let me write that. X plus 8 equals 17. And when you subtract 8 on both sides, you'll get x equaling, when you subtract 8 here and subtract 8 over here, x equals 9. Okay. So what's the real answer?
She scored 9.
She scored 9 2-pointers, right? 9 2-pointers. So let's write that. She scored 9 2-pointers. I hope you guys understand that. All right, number 3, coins. Pepito has a jar of nickels and dimes. He has a total of 65 coins, nickels and dimes that is, with a total of $5.45. How many nickels did Pepito have? Okay, so what are we dealing with here? Are we dealing with points and baskets? What are we dealing with?
Money.
Money? Okay, so, and nickels and dimes, right? So let's start first with an equation based on nickels and dimes. So based on the number of coins, yeah?
Yeah.
So how many coins are there?
65.
65 total, right? So it says up here, total is 65. So I know that I have a total of 65 coins, making an equation on the number of coins. Now the question is, do we know how many nickels? No. Do we know how many dimes? No. So we're going to say, I don't know how many nickels and I don't know how many dimes, but I know if I add them together, it'll give me a total of 65 coins. And ladies and gentlemen, this is an equation based on the number of coins. Now, what other factor do we have in this problem? Not just number of coins, but we also have actual money, right? Like the actual value. How much total value does Papito have? $5.25? 45. Okay. So we know that it's a grand total of $5.45, right? So, but what about the nickels? How much is each nickel worth? 5 cents, right? So we're going to put 0.05 times the nickels, because each nickel is worth 5 cents, plus how much is a dime worth? 10 cents. So you're going to put 0.10 times D. So ladies and gentlemen, this is our system right here that we need to solve. And that's half the battle right there, creating the system of equations that you need to solve based on the words. Okay? So, a lot of people get confused because there's decimals involved. So, if we were to multiply the bottom one by 100, that'll make all the decimal places move over 2 places. So, this 0.05 will become 5n. This 0.10 will become 10d. This 5.45 will become 545. So I am multiplying the whole bottom equation by 100 to get a new equation without decimals. So let me just rewrite the top one. I'm not going to mess with the top one right now. N plus D equals 65. The bottom one's going to become 5n. Actually, let me do it. Yeah, I'll keep it in red. 5n plus 10d equals 545. So now we have this new system without decimals, and we want to eliminate either the n's or the d's. So which one would you prefer to eliminate, n's or d's? N's. Okay, so how would I do that? How would I do that? Multiply that top equation by -5. That's great. Okay, so let's rewrite it. We have a -5n, we have a -5d, and we have 65. This is a great section for calculators, guys, because obviously 65 times -5 is -325. And that bottom equation, we're going to leave the same. 5n plus 10d equals 545. And now we're ready to combine the lines, linear combinations, eliminate the n's, and we'll get positive 5d equals, with the calculator, let's go 545, take away 325. And we'll get 220. Yay?
Yay.
Final step will be to divide by 5, divide by 5. So we'll get the dimes is a total of 44. So we're talking about 44 dimes here. Now, the question is, are they asking for how many dimes does he have?
Asking for nickels.
For nickels. Okay, so what must we do to find out how many nickels?
Plug it in, take the 44.
Take the 44 and plug it into the D right there. So your new equation when you substitute will be n plus 44 equals 65. So all you end up doing is subtracting the 44 on both sides. And with the calculator, 65 take away 44, it's going to be n equals 21. So the answer there is, is 21. So he had 21 nickels and 44 dimes, but all they're asking for is a nickel, so 21 nickels. That's your answer, 21 nickels. All right, number 4. Illegal sales at school. Juanito, he sells Flaming Hot Cheetos for $1 and Takis for 75 cents during his classes and at lunchtime all day at school. In one day, Juanito sold 30 bags and made a total of $26.75. So how many bags of Takis did he sell on that day? So we need to create 2 equations. What are the 2 things we're dealing with here on this situation? Hot Cheetos and what? Takis. Okay, so we need an equation based on the number of bags. And we need another equation based on money. Money. Okay. So the first equation based on the number of bags, well, do we know how many Cheeto bags he sold? No. So we're just going to put C for the number of bags of Cheetos. And do we know how many Takis bags? No. So we're just going to put a T for the number of bags of Takis. Do we know the total bags that he sold on one day?
It's 30.
Yeah, 30. So C plus T is a total of 30. And this is an equation based on the number of bags, right? I don't know how many Cheeto bags, I don't know how many Takis bags, but I know when I add the bags together, it's a total of 30 bags. And now let's go for making an equation based on money. So how much does each Cheeto bag cost? $1. So I'm going to put 1 times C, 1C. How much is each Takis bag? 75 cents. So I'm going to put plus 75 cents is 0.75 times T. And we know that the grand total that he made was $26.75. So we do have decimals here. So at this point, we could do what we did before. We could multiply everything by 100 to move the decimal places over. But since we're going to be using calculators anyway, why not just deal with the decimal, especially because right here we have a positive 1C and a positive 1C. What could I do to cancel out C's? Multiply one of them by a -1, right? So I'm going to multiply the bottom one by -1, but you can multiply any one you want by -1. So the top one I'm going to keep the same. C plus T equals 30. And the other one is going to be now -1C minus 0.75T equals -26.75. I know it's ugly, I'm sorry. But now we could combine these lines and the C's will cancel. So when we combine the lines, the Cheetos eliminate. And what is 1 whole take away 0.75? That's like saying $1 take away 75 cents. You have 25 left over. So what do I have now? I have a 0.25 of these T's, which are Takis, equals, and what is 30 take away 26.75? Let me do that on the calculator. 30 take away 26.75 on the calculator is $3.25. So we have $3.25. So for my final step here, to get rid of the 0.25 that's being multiplied in front of the T, I have to divide by 0.25. That way it'd cancel. And we do to one side and do to the other. And with the calculator, if you go 3.25 divided by 0.25, you will get 13. So T equals 13. What did I find? I found that this guy sold 13 bags of Takis. Is that what they're asking for? Is that what the question's asking for? Yeah. How many bags of Takis did he sell? 13. I'm done. Now, if they would have asked for bags of Cheetos, then I have to go back and substitute in. All right. Last question here. Museum field trip. A group of second graders are going on a field trip. An adult ticket costs $6 and a child ticket costs $4. There were 32 tickets purchased for a total of $184. How many children went on this field trip? Okay. So we have chaperones and we have students. So we're going to make two equations. One based on the number of tickets. And the other one based on money. Okay. So number of tickets. Do we know how many adult tickets were sold? No. Do we know how many children tickets were sold? No. But I know if I added them together, they tell us that they sold a total of 32 tickets, right? So there's an equation based on the number of tickets. Now we're going to write an equation based on money. All right. Now what do I mean by based on money? How much is each adult ticket? $6. So I'm going to put 6 times A, because if you sold 10 adult tickets, that'd be $60, right? So 6 times whatever number of adult tickets were sold, plus how much are the children tickets? $4 times however many children's tickets were sold. I know it'll give me my grand total of $184. So the top equation was based on number of tickets. It's right there. The bottom equation is based on money. It's right there. So this is our system that we need to solve. So we either need to cancel out A's or C's. What would you rather cancel out? A's? Okay. So if you wanted to cancel out A's, you'd have to multiply this top one by what? By -6. So let me multiply that top equation by -6. I'll get -6A minus 6C equals, here's the hard one, 32 times -6, -192. So that's my new modified top equation. My bottom one's going to stay the same. It says 6a plus 4c equals 184. And now we're able to combine the lines, eliminate the a's, the adult tickets. We end up with -2c equals -192 plus 184 is -8. I know it's weird, we have negative children tickets, but see, it works out because when you divide by -2 right there, it goes back to positive. So C equals 4. So what do we find out here? We found out how many children went on this trip, which is really weird for a second grade field trip, right? Only 4 kids went and the rest were adults. All right, anyway, so yeah, the answer is 4 children went. And that's a huge video. I apologize, but it is explaining every single type of word problem that we could see on next Monday's test.